Welcome back. It is time for Astronomy in the News. I am Astrobit, also known as Brian W. Mulligan.
And I am Major Merger, also known as Sinclaire M. Manning. Are we doing middle names today? Okay.
I've just got a generic name. I need mine. Most research in astronomy is funding through federal agencies, the best known, of course, being NASA, which funds about 60%. The NSF and Department of Energy fund the remaining 40%. The NASA budget proposal maintains funding for the James Webb Space Telescope, but it entirely cuts the Wide Field Infrared Survey Telescope, or WFIRST.
Boo. Right reaction.
However, that telescope's been a little bit controversial within the field in terms of what exactly its scope is, and all of the funding from it is at least staying in the astrophysics budget for NASA. So it's it's okay. It's okay. The proposal, however, also suggests ending funding for the International Space Station as of 2025. Boo. As a whole, though, the NASA budget is only cut by less than 1%. Not too bad. However, the proposed NSF budget includes a nearly 30% cut over its 2017 level. And as the proposal does not include a chapter on the NSF, we have no idea what their intent for that actually is. It also cuts the science-related budget for the Department of Energy by about 20%, increasing the funding for nuclear security, however, by 18%. The budget now goes to the congressional committees for review and debate. The House and Senate budget committees held their first hearings last week. No further hearings are currently scheduled. In the past, most of these proposals have largely been ignored by Congress. The last budget by this administration was completely ignored by Congress. So that's promising. However, just in case, we do have tip jars over at the merchandise table. Please feel free to contribute.
A lot of us are funded by NSF. We need that money. All right, so NASA confirmed that an amateur astronomer discovered signals from a spacecraft that had been lost for 12 years. Oh. The image satellite, shown here on the left, launched in 2000 with the goal of imaging the Earth's magnetosphere, which is the invisible sphere of plasma surrounding the Earth that shields our planet from the harsh solar winds. So IMAGE sent us some awesome images, like the one pictured on the top right, showing an enormous solar storm, and provided a lot of new information about the magnetosphere. But in December of 2005, the satellite suddenly stopped sending images and went quiet. So it was believed that the craft's power supply subsystems failed, and so for more than a decade, the spacecraft continued to circle the Earth unseen. That is, until January 20th, when Scott Tilley, shown at the bottom right, an electrical engineer from Canada, heard a radio signal that he was not expecting. I actually find it pretty hilarious that he was actually scanning the sky for a radio signal from a secret satellite, codenamed Zuma, that was launched by a private company on January 7th by an unknown government agency. So there's just like a lot of mystery around this satellite. So it reportedly failed immediately, but it was never publicly stated what went wrong with Zuma or what its purpose was. So this did not sit well with Tilley, who is and he's part of a group of amateur astronomers who are against the use of secret military satellites and classified orbits, as some of you may also be part of this group. I don't know. So while scanning the sky for radio signals of Zuma, he repeatedly came across the signal that eventually discovered belonged to IMAGE. And after contacting NASA, their scientists looked into it and have since confirmed that it is indeed the IMAGE spacecraft that Tilley heard. So there's quite a bit more to the story, like why the spacecraft switched off and back on again, but it's been suggested that the main control system is operational, so perhaps we will be hearing more from IMAGE in the future.
Yes, God.
Okay, so the New Horizons probe now holds the record for taking images the furthest from the Earth. So the images of two distant bodies, shown here, the gray or green blobs on screen. These are Images from bodies in the outskirts of the solar system, they were taken on December 5th by the Long Range Reconnaissance Imager. At the time, the New Horizons probe was at a distance of about 40 times further from the Sun than is the Earth, or about 3.79 billion miles. The previous record was set by the Voyager 1 probe in 1990, when it was only 3.75 billion miles from Earth. The Voyager probes were launched in the 1970s. They are further away from the Earth than the New Horizons probe, but their cameras were switched off decades ago in order to conserve power. New Horizons, of course, was the first probe to visit Pluto and is now on an extended mission to explore the nearby outer reaches of the solar system called the Kuiper Belt. This is a region of debris that is left over from the formation of the solar system. New Horizons will encounter an object named MU69 on New Year's Day of 2019, and it'll be the first ever nearby imaging of a Kuiper Belt object. The images and other data that are taken in this encounter will give us more insight on the composition and formation of our solar system.
All right, so the Kepler Space Telescope continues to do a fantastic job of finding exoplanets. For those who don't know, Kepler launched in March of 2009, and for 4 years, the spacecraft continuously stared at around 150,000 stars, looking for transiting exoplanets. But unfortunately, in May 2013, one of the reaction wheels used to maintain the spacecraft's orientation failed, bringing the original mission to a close. But luckily, scientists worked quickly and were able to continue to use Kepler for its current extended mission known as K2. So astronomers have been poring over the data provided by K2, and a recent study adds another 95 exoplanets to the known population. And one of the newly discovered exoplanets is even a record breaker, as it is in a 10-day orbit over what is now the brightest star found by Kepler or K2 that hosts a validated planet. So this brings the exoplanet tally up to 292 for K2 and the total haul over Kepler's operational lifetime to 2,440. So plus there are more than 2,000 additional Kepler candidates awaiting confirmation by follow-up observations and analysis. So there are many more planets to come. Yes, aliens, come on.
They're out there. What was his name? Scott Kepler? He'll find him.
Yeah, Tilly will get him.
Tiller. All right, so the first potential extragalactic planets have been found. So the first possible evidence of planets outside of our own galaxy have been identified by Xinyu Dai. I apologize if I'm butchering his name, if anybody speaks Chinese. I think there's a couple in the audience. Xinyu Dai of the University of Oklahoma investigated a distant quasar that has some unusual properties that they claim is the result of planets passing between us and the quasar. A quasar is a supermassive black hole in the center of a galaxy into which gas and dust is falling and emitting a lot of heat and light in the process. The light from this particular quasar shows occasional shifts in the speed of the material that's falling into it. They claim that the pattern of these shifts are consistent with planets passing in front of the quasar, between the quasar and us, and causing a very slight bending of the light due to the weak gravity of the planets. While this process is very well understood and has been observed for planets within our own galaxy, this process has never been seen in a distant galaxy. However, the results are controversial, in part because they find that there are nearly 2,000 planets for every star within the galaxy. I know of 8 in our solar system. So obviously a lot more than have been observed within our own galaxy through a variety of means. The shifts in the light of this quasar could also be explained by more conventional irregularities in the gas and dust around the black hole, although it's probable that at least some of these shifts are in fact due to planets.
All right, last up, astronomy not in the news. I cheated a little bit on this because Trappist I was definitely in the news a year ago or so, but a new development for all of you that may be interested. But so Trappist I, if you don't know, was a 7-planet system located fairly close to our own solar system at a little over 39 light years away, with 4 planets in the habitable zone around its host star. So what made this system a bit different than our own solar system, though, is that all of the planet's orbits fit into a space smaller than the orbit of Mercury, which you can see in the top left picture. So yeah, it's very compact. So authors of a recent paper have used the Hubble Space Telescope to follow up on the 4 planets in the habitable zone to figure out if they have atmospheres similar to Earth and thus potentially be suitable for life. So shown here at the bottom right are the transmission spectra for the 4 planets. So the black points are the actual data from the Hubble Space Telescope. And thank you, Brian. And the colored lines are different models showing varying atmospheric conditions. So if the data match up with any of these lines, you can infer what molecules are present in that planet's atmosphere. So based on this plot, the authors say that a hydrogen-rich atmosphere doesn't match up with observations for planet D, E, and F, and the hydrogen-rich is the red line and the orange line. And D, E, and F are the top left, bottom left, and the top right. But can't be completely ruled out for G, which is the bottom right. But for the nearer planets D, E, and F, many atmospheric scenarios are possible with the given spectra. So it could be dominated by water, by nitrogen, by carbon dioxide, which are the blue, green, and gray flatter lines that you can see in the plot. So hazes and high-altitude clouds were also inferred through the lack of spectroscopic signatures at near-infrared wavelengths, and that would normally point to a cloud-free, hydrogen-dominated atmosphere. So through all this analysis, the authors conclude that Trappist I, D, E, F, and G are terrestrial and potentially habitable. So that's pretty cool. But once the James Webb Space Telescope comes online, astronomers can take an even closer look at these systems and work to further improve our understanding of these alien worlds.
And expect Elon Musk to plan a space flight next week.
Send a Tesla over there.
All right, that's all for Astronomy in the News for February 2018. Thank you all for coming.
Thank you very much.
And enjoy the rest of the show.